Yeah, good evening everyone. Good evening. Let's check audio video okay or not. Yeah, let's check audio video okay or not. I hope everything is fine. Yeah, we can start now. We can start. I think today's date, if you see, I think 20. Today's date is 20. Yeah, let's go ahead. So I'm writing now 20, 11, 25. Today's date is 20, 11, 25. So it's the time complexity finding 3. It is the last class of time complexity. Today is the last class of the time complexity, right? I'm starting now. In the yesterday's class, I stopped at 21. Question number 21, I stopped, right? If anyone not done, if you are not done yesterday's class, day before yesterday's class, I request you, please go through it. Yesterday, time complexity 1 I done. Sorry, day before yesterday, time complexity 1 I done, right? Yesterday, time complexity 2 I done. Today is time complexity 3. Right? I think every class is approximately 45 minutes to 1 hour. Every class is 45 minutes to 1 hour. Within 2.5 hours, you will get the total time complexity. Right? Let's complete the today's class. Let's complete the today's class. 20, 11, 25. I'm starting now. Today, question number 22 is the starting one. Let's start. Question number 22. Yeah, start now. See the problem one time. See the problem one time. Yesterday we done. It's the continuation of the yesterday's class. So I is equal to I by 2, I is equal to I by 7. If you observe, first by 2, next by 7. It's totally, right? I think I by 14. So it is equal to, I is equal to I by 14. Means overall I is decrementing. Overall I is decrementing. That means initial I value is a bigger number because you are decrementing. Your decrementing means initial I value is a bigger number. So in the loop, you are decrementing until termination condition happened. Termination condition is I greater than 75. So I value becomes 75, 75 greater than 75, condition fail. So I think everyone know, if you always divide by 14, 14, 14, I think time complexity becomes log n base 14. You know this very well. Time complexity log n base 14. If you want, you can do the proof also. If you want, you can do the proof also, right? I think most probably it is done. So you can verify yourself, right? It became the series n by 14 power k is equal to 75. Decrementing until n by 14 power k is equal to 75. So it become n is equal to 75 into 14 power k. So log n base 2 is equal to, log n base 14 is equal to, right? I think it will become k plus log 75 base 14. Right? Finally, k becomes log n base 14. Remaining is anyhow some constant. Right? Finally, answer is going to be log, right? Log, right? If you observe clearly, so it is a log a by b formula kind of thing. Log a by b formula. It became log n by 75 base 14. Right? Yeah, indirectly, it is going to be log n base 14 only. Simple. No need to do this much work. I given proof purpose. I given for your convenience everything. Simple. Every time you are dividing by 14. Always divide by 14, 14, 14, 14. So answer is log n base 14. If you want a actual thing, this is the thing. First n will be there. Next n by 14 will be there. Next n by 14 square will be there. And so on. If you do 2 times, this is the story. If you do k time, n by 14 power k, which became termination condition 75. Right? I think this is the story. From here onwards, normal. All the total story I written see. So time complexity of question number 22, log n base 14, right? And one more, anyhow 14 is a constant, no need to bother also. If this is there in the option, you select. If not there, you can simply write like this also, log n, that's it. Forget about base. Forget about base. Simply you can write log n. Simply you can write log n. So question number 22, answer is log n. If at all anyone asks you, say base also, then log n base 14. If anyone asks you, say clearly, right, I don't want log n base 14, can you say one more step before, then say this, log n by 75 base 14, right? How you got like this? This is log a, right? Log a by b formula. Log a by b base c is equal to log a base c minus log b base c. Same thing like that, right? Same thing like this, log a by b base c, same formula, log a base c minus log b base c, same story. So like that it came, right? Please verify properly. Small doubt also there in the comment section, you can comment. So question number 22 I done. What is the question number 23? Go to the question number 23. Everyone try to see this one. Question number 23. I is equal to 270. While I less than n, I is equal to 2 into I is equal to 3 into I is equal to 4 into I is equal to 270, while I less than n, I is equal to 2 into I is equal to 3 into I is equal to 4 into I. I think if you observe clearly, first 2 into I, for that into 3, for that into 4, finally 2, 3, 6, 6, 4, 24. So this became, you know very well. This became, you know very well. So what is the answer? I is equal to 24 into I is equal to 24 into I. Always multiply by 4. But your increasing means initial I value small. Small means some constant. It need not be 1. When I say small, it need not be 1. It may be 2. It may be 3. Some constant. In algorithm terminology, every constant is same. Either a 1 or a 10 or a 25, 36, whatever it is. Or 270 or 100, 1 lakh, whatever it is. Every constant is same. Don't think much about that constant. Some constant will be there. So initially I is equal to 270, then I is keep on incrementing every time by into 24. I think always multiply by 24. Everyone know, right? Into 2 is nothing but divide by 2. The only thing is start from big number, you will divide. Start from small number, you will multiply. So answer is going to be log n base 24. Answer is log n base 24. If you want clear, just go for the proof. You want clarity, then every time you no need to do right proof and all. Really required, then only do. So if you see the series, it is something like, if you see the series, something like it is coming, right? 24 power 1, 24 power 2, and so on. 24 power k will come, right? 24 power k will come, right? Something like that. So this kind of thing, finally log n base 24 will come. Every time proof not required. If you really required, whatever way I done in the previous, right, in the previous, for the previous problem, do similar way. Whatever I done for the previous problem, do similar way. How? If you want, you can check. I think only for namesake I am doing. No namesake. First to 270. Next to 270 into 24 power 1. Next to 270 into 24 power 2. If I continue k time, 270 into 24 power k. Increasing, it became n. Right? It became n. Now you want k value. Apply log, same story. Log n base 24 is equal to, right? It became log 270 base 24, right? It is a log AB formula plus k. Log of AB is equal to log A plus log B. Log A plus log B. So it became like that. Finally, k is equal to log n base 24 minus log 270 base 24. Right? Common base. I think same story, which will goes to, right, log n by 270 base 24. Same story like above problem. Right? Which will goes to, right, n by 270, which is nothing but n. Log n base 24. If you don't bother about base, simply you can write log n also. Simply you can write log n also. I hope everyone is comfortable. Same story, same story. Always dividing by 24. Log n base 24. Right? If log n base 24 there in the option, well and good. Otherwise you can write simply log n. Simply you can write log n. Simply you can write log n. Question number 23 also I done. Go to the question number 24. Go to the question number 24. Go to the question number 24. Right? Main. I is equal to 2. While I less than n, I is equal to I square. Here the series of iteration of I goes as 2, 2 square, 2 power 4 and so on. So I think you can see this. This problem, it is a new model. Everyone can see. It is a new model. This problem is the new model. Until now multiplication division is over. Until now multiplication division is over. Now you can see. Until now multiplication and division is over. Now new model is coming, power coming. See, every time, right? Every time. Previously 2 into I. Now I power 2. I think it is incrementing so faster. If at all always into 2, into 2, into 2, it became log n base 2. But it is not into 2. I power 2, I power will increase more. Suppose assume, right? I value 10. So 10 into 2 is 20. 10 plus 2 is 12. But 10 power 2, 10 square 100. There is a big change. Right? If I do plus 2, 10 plus 2 is 12. If I do into 2, 10 into 2 is 20. Comparing to 12, 20 is going more faster. More faster means less time complexity. If you do any work with faster, definitely less time it will take. Suppose, right, 10 power 2, 100. One is 12, another is 20, another is 100. So someone is going so faster. So time complexity is very less. So here always power 2, always power 2, always power 2. If you observe clearly, this will leads to log n. Proof also available. If you want, I will explain also. See, already I written also. Already I written log n is the answer. If you want, I will give the proof also. I written already. I will explain here. Can you see this one? I will explain. Initially, I value 2. Everyone observe. Initially, I value 2. Then whatever you have, whole power 2, it became 4. Whatever you have, again whole power 2, 4 square, 16. Whatever you have, whole power 2 again. So 16 square, 256. So whatever you have, whole square. Whatever you have, whole square. Now, if you observe clearly this one, it became 2 power 0. 2 power 0 is 1. 2 power 1 is 2. This one, if you observe, if you want, you can check. 2 power 1. 2 power 1 is 2. 2 power 2 is 4. This one, if you observe, 2 power 2 square. 2 square is 4. 2 power 4 is 16. This can be written as 2 power 2 cube. 2 cube is 8. 2 power 8 is 256. I think if I do 3 times, it is a 2 power 3. If I do 2 times, 2 power 2. If I do k time, this became 2 power k. If I do k time, it became 2 power k. Increasing, something like that. Finally, right, after increasing so many times, this became n. Equal to n, you can stop it. Equal to n, you can stop it. I think that's what it done. See, same thing it done. I think, but if you observe clearly here, 2 powers are there. 2 power k. 2 power k. Because of 2 powers, you have to apply 2 logs. Because of 2 powers are there, you have to apply 2 logs. When you apply first time, it will go. When you apply second time, it will go. So 2 times you have to apply log. So this is one. 2 power k is equal to n. If you apply log base to 1 time, so it became log n base to right side. Left side is 2 power k into log 2 base 2, which is 1. If you apply one more time, log n base to left side, k into log 2 base 2, it became 1. Right? Finally, log n base 2. So k is log n base 2. So time complexity log n base 2 base 2. right? So if you want, you can write the log of log n also. Log of log n also you can write. Log of log n also you can write. Base if you don't write also no problem, because anyhow it is constant. So it's an excellent problem. It is an excellent problem. It is an excellent problem. And one more thing everyone, one more thing observe here. Why are you applying first time log base 2 to eliminate this 2? Why are you applying second time also log to eliminate this 2? To eliminate the base, first base, to eliminate the base to this 2, I am applying first base as 2. To eliminate one more time this 2, right? I applied second time also 2. Inner one is the first one, right? Outer one is the last one. You may say that, why these 2 came first? What is the reason? That 2 came from here, starting one. Why second power also? See this one, these 2 came from because of this reason. Next one, some people are asking, these 2 came from here, okay, from where these 2 came? These 2 came from here, these 2 came from here. Inner loop 2 came in the power, right? Outside 2 came, right, starting base, right, like that. So if you, for more clarity, you can see the next problem. See the question number 25. 24 we done. I think everyone knows. See, very simple. In the power, answer is log n. Understand? In the power, right? You are incrementing always by power. Answer is log n. For more clarity, you can see this problem. For more clarity, you can see this problem. See, always I is equal to I power 3. Always I is equal to I power 3. Remember, inner base will come this one. Outer base will come from this. Right? So answer, if you want, you can check log of log n, inner base, right? Log of log n, inner base, if you observe, inner base 25, outer base 3. Right? This person is power, na? He will come after some time. But this person is direct, starting itself, he will come. So inner one means starting, 25. Outer one means outs, right? Lastly, he will come. So 3. So answer is big O of log n. If you want base also, inner base 25, outer base 3. If you want proof also available here, you can check properly here. Properly. So how the series will start? Very simple. 25 here. Next one, 25, 3 power 1. 25, 3 power 2. Check properly if you want. Continue k times. 25, 3 power k. It will become like this. Apply log. So remember, inner, right? Initial one is 25. Apply log base 25, so that he will go. Next one, I think now this person fall down. Now apply base 3. Then, right, when you apply base 3, right, I think he will also go. Log 3 base 3 also will go. So finally, k is log n. Inner base is 25, outer base is 3. Right? If at all it is there in the option, it's okay. Otherwise, answer is log of log n. Log of log n base 2. Log of log n base 2. Right? I think n, right? If at all, right, this is already there, it's okay. Otherwise, base also you no need to write. Otherwise, base also you no need to write. So question number 25 also over. Go to the question number 26. Go to question number 26. Question number 26. 25 over. Go to the question number 26. Right? I think remember power reverse is root. I square, right? I square. Initially I is there. If I do square, it became I square. If I do root, it became I. So what I mean to say is square, whatever way increasing. If I do root, same way it will decrease. Same way will decrease. Let's check here. 2, square it, 4, square it, 16, square it, 256, square it, 256 whole square. 256 whole square. This is if you do square, right? If you do root, reverse. Both will be log n. Both are log n. Both are log of log n. Both are log of log n. Try to understand. Both are log of log n. Both are log of log n. right? Whatever way square is doing, root also will do same. The only thing is, right, if at all small, square it. If at all big, root it. This is the only difference, right? Otherwise, both are same. In my opinion, both are same, right? I think you can see the proof also. See the proof. See the proof one time. I is initially n, right? Next one, n power 1 by 2. Same story. Don't by heart anything. Until you are confirmed, keep on do proof. When you confirm, directly do. N first. Next one, n power 1 by 2. Next one, n power 1 by 2 cube. N power 1 by 2 cube. Next one, n power 1 by 2 power 4. If I do 4 times, this is the story. If I do k time, n power 1 by 2 power k. Remember, decreasing, it became 2. It became 2 until continue. So same story. Now remember, you are able to see these two first. Apply base 2, log 2 base 2 becomes 1. Next one, I think this person will fall down. So it became like this. Again to make him as, right, again 1. Apply log 2 base 2 again, right? Log 2 apply, right? Then it became 1. 2 times. Finally, k becomes log n. Base 2 base 2. Remember everyone, this base starting 1 is inner 2, right? In the power 2 is outer 1. Starting 1 is going to be inner 1, right? Power 1 is outer 1. So answer is log n base 2. Both are base 2. So k is time complexity log n base 2. If you can write like that, it's okay. Otherwise, without base also you can write. Log of log n. Remember, root reverse is square. Square reverse is root. Both will give same time complexity. Both will give same time complexity. Try to understand. Question number 26 also done. Can you go to question number 27? Everyone try to understand. Go to question number 27. Right? Same thing one more time. Very, very interesting. Some people are asking, sir, before starting, can you say the time complexity directly? See this one? I think root or power, both will be same time complexity. Log of log n. Both will be same time complexity. Log of log n. That is okay. But remember, right? Remember everyone, starting 1. I think this number I am able to see because he is not there in the power. So this person whom I can see directly, that person is inner. The person who is there in the power, whoever is there, that person is outer. So answer is big O of log n. Inner one is 64, outer one 51. If you want, you can do proof also. Whatever way I done over, you can do here also. Some people are asking, sir, how, sir? Can you see this one? N first. Next one, n power 1 by 51. Next one, n power 1 by 51 square. Next one, n power 1 by 51 cube. Continue. n power 1 by 51 whole power k. Decreasing, almost equal to 64. Stop it. Remember, this person is there in the upper. So this number only I am able to see first. So I have to eliminate this number. So log 64 apply first. Okay. Next apply. This number will fall down. Then apply, right? Log base 51 you do this one. So answer is log n. Base 64 inside, base 51 outside. Right? That is the answer. Perfect. Go to the question number 28. I think everyone observe. See this one. You are starting with small number. Means inside the loop you have to increment. Increment means power. Understand? So first to I power 31. Okay. Now whatever you have, to that whole square. Remember, a power m whole power n. A power mn. So multiply. It became I power 62. Whatever you have, whole power 3. A power m whole power n. A power mn. Right? I power 62 into 3. Which is going to be, I think 3 2 6 3 16 18. So 186 I think. So I power 186. 326, 3618. I power 186. I power 186. So answer is always power 186. Answer is everyone know log n. Inner base is, remember, inner base is starting one is this 25. Outer base is power person. Power is this 186. This is the answer. Question number 28 also done. Question number 28 also done. Can you go to question number 29? Very interesting one, right? Question number 29 is going to be very simple. See, I think it is a mixed do, but remember everyone, it is a mixed do, right? So both the operators are reverse to each other, right? So there may be chance that he will give in one loop only both. There may be chance that he will give everything in one loop only. Everything in one loop only, there may be a chance he will go, because they both are reverse to each other. There may be chance of cancellation and all, right? But understand, see this one, very small number first. So inside loop, it should increase finally. Suppose already small, inside loop decrementing, I think termination condition never happened. So I think a program will go to infinite loop, means time complexity we cannot find out, means undefined. So definitely, because of starting the small, inside should be increment. So let's check. First I power 5, okay. Next, whatever you have, whole power 7. It became I power 35. Whatever you have, whole square. It became whole square. It became I power 70. It became I power 70. Whatever you have, whole square. It became I power 140. Right? Understand everyone. Whatever you have, whole power 1 by 4. 1 by 4, which is nothing but a power m whole power n, a power mn. So it became I power 140 into 1 by 4. So 4 ones, 4 threes 12. 4, right, 20 there, 4 fives 30, 4 fives 20. Right, 4 threes 12, so 2 there, right? Next one is 4 fives 20, 35. So overall it became, if you observe clearly, overall it became I power 35. Overall, if you observe, I power 35. I power 35. Oh, I think, do you believe or not, starting is small number. Inside loop power, I think definitely it will increase. No problem at all. I think because of always whole power 35, this is also log n is the answer. Inner base is this person, 64. Outer base is this person, 35. So answer is log n, inner 64, outer 35. Exactly. So question number 30 also over. So 29 is over. What is question number 30? Go to the question number 30. Everyone see question number 30. Main, I is equal to 10, while I less than or equal to n. I is equal to I plus 7. I is equal to I into 10. I is equal to I power 9. Right? Something like that it is given. So can you see this one? Already started with small. So inside you should increase. Let's see what he is doing. See the answer. I plus 7 first. Increasing. Okay. Next one. Whatever you have into 10. That is also okay. Whatever you have, further into 10. Next one. Whatever you have, whole power 9. Do you believe or not? Calculating this much big number is going to be a little difficult. So instead of taking all, the best thing is small thing neglect. See, comparing plus and multiplication is increasing faster. Comparing 10 and power will increase. So don't think much. It became I power 9 only. So this problem is combination of addition also, multiplication also, power also. But you know very well, power will dominate more. Power will dominate more. Power will dominate more. So take power only. So these two people are only for namesake. These two people are only for namesake. I is equal to I power 9. Right? So even though all three there, final meaning is same only. So I power 9 only. I think power answer is same. Log n. Right? But inner base is this 10. Outer base is 9. We go off log n. That is the answer for this. See, check. Right? Question number 31. See the question number 31. Right? Based on all the basics, based on all our basics, whatever we done till now. One problem. Can you see this one? I think 3 for loops are there. 3 for loops. Everyone observe. 3 for loops are there. See the inner loops. 3 for loops are there. Can you see the inner loop? 3 for loops. Can you see the inner loop? For k is equal to 1, k greater than k power 25, k is equal to 1, k power 27, right? Less than n power 5, k plus plus. Right? And one more, I think, what about I loop? I is always, right? See this one. If you observe clearly, I is always incrementing by plus 1. K also always incrementing by plus 1. See, how it is incrementing, that will decide the time complexity. Wherever power there, please don't go. Wherever power there, please don't go. I is always incrementing by 1. It's not incrementing I power something. I is always incrementing plus 1, plus 1, plus 1. J is always decrementing by 3, by 3, by 3. See, J started with a big number. Always it is divided by 3, 3, 3, divide. So it is divided always by 3. Right? I think if you always divide by 3, you know very well. Log n base 3. It is always going plus 1, plus 1, plus 1. It is actually time complexity n only. But he is doing some small story here. I will check. Observe carefully. Observe carefully. Right? Don't confuse. Within few minutes, you will get the clarity. Right? Right? Listen, everyone. Now, whatever basics we got till now, using all basics, I want to solve one problem. I'm solving. Right? So if you see the J loop is always decrementing divide 3, divide 3, divide 3. So it is a log n base 3. Divide and multiplication is log n will come. If at all power there, root there, log n. Only plus there n. I think actually I loop, actually n, but what is going on you will get to know. What is going on you will get to know. Right? So condition checking time is not checking I less than or equal to n. He is checking I cube is less than or equal to n. What exactly meaning? I will check. See this one. I value initially 1. Okay. 1 cube. First you will check. 1 cube is less than or equal to n or not. If it is true, you will continue further. Next I value becomes 2. You will check 2 cube is less than or equal to n or not. Suppose it is also true. Next I value becomes 3. You will check 3 cube is less than or equal to n or not. If that is also true, you will check. Right? I value became 4. Right? 4 power 3 less than or equal to n or not. Right? Like that you will keep on check. I think if you keep on continue k time, then what happened is k power 3 is equal to n, it will become. Lastly, after repeating k time, let us assume k cube is equal to nk. Right? I think if k cube is equal to n, what is the k value? Right? I think then what is the answer? I think k cube is equal, right? Just apply 1 by 3. Whole power 1 by 3. Because I want k value. Right? Both the side do power 1 by 3. Then it became k. K is equal to n power 1 by 3. N power 1 by 3. So remember, right? First loop is n power 1 by 3. Be careful. Don't do anything blindly. So I loop n power 1 by 3. J loop log n base 3. Observe carefully k loop also. Easily you will get. See the k loop. K also always plus 1 only. So what is the meaning? First you verified 1 power 27. K value initially 1. 1 power 27 is less than or equal to n power 5 or not? Yes, true. Assume it is true. In the next round, k value become 2. 2 power 27 is less than or equal to n power 5 or not? If that is also true, next one, 3 power 27 is less than or equal to n power 5 or not? If that is also true, continue. It became, right? So k times assume. K power 27 is equal to, after repeating k time, both became equal. Assume n power 5. So finally I want k value. So k power 27, be careful, whole power 1 by 27. Because I want k. 1 by 27 is equal to n power 5 whole power whole power 1 by 27 means it became 5 by 27. Check properly. So finally k become n power 5 by 27. Check properly. So finally k loop is right, n power 5 by 27. So let me write n power 5 by 27. And one more, remember, these are inner loops. These are inner loops. These are inner loops. You have to multiply. These are inner loops. Multiply all three. This one, this one, this one. Multiply all three. Then when you multiply, it became n power 1 by 3. It became log n. It became n power 5 by 27. Right? So whatever it is, just add properly, big O of. Whatever it is there, just add properly, big O of n power 1 by 3 into log n base 3 into n power 5 by 27. Right? So that is the answer for that problem. Right? For this problem, answer is going to be n power 1 by 3 into log n into n power 5 by 27. This is the problem number 31. Right? Let's see the problem number. Right? Problem number. I think is it same problem? Yeah, it is a different problem. Similar way, this also. Right? I think problem number, it is a 32, I think. I will change afterwards number. Please careful. This is a 33. $34. Yeah, totally 34 problems. Yeah, let me do 32. Yeah, 32 I am doing, 31 over. See the 32. It is also, remember, it is also inner loops. Inner loops means you have to multiply. Careful everyone, it is also inner loop. Inner loop means you have to multiply. Observe properly, always I incremented by 1. If I incremented by 1, so if it is n means n time. So n power 1 by 3. N place n power 1 by 3 there, whatever there, keep it. Always incrementing plus 1, plus 1, plus 1. So n by 1. If n there, n by 1. But n power 1 by 3 there. Whatever there, right? Whatever there, that one by 1. Next one. Always divide by 3. Log n base 3. Always divide by 3. Log n base 3. Next one. This is, I think if you observe clearly, this is also always plus 1. If always plus 1, n by 1. N is there, n by 1. Right? N power 5 by 27 there, 5 by 27. So multiply all three because of inner loops. Multiply all three. Same thing multiply. So I think this is the same answer. Log n base 3 is a one person. N power 5 by 27 is another person. N power 1 by 3 is another person. Right? Simplify as much as possible. So that is the question number 32. Go to the question number 33. Go to the question number 33. Remember, these are also inner loops. Inner loop means you have to multiply. Inner loops means you have to multiply. Let's see. So if you observe clearly outside, always into 2. Always into 2. If you at all always into 2, log n base 2. See, n is there, n. N square there, n square. Log n square base 2. Always into 2, log n base 2. N there, log n base 2. N square there, log n square base 2. Whatever is there, log of it. Right? First loop, I loop is how many times? Always into 2, log n base 2. If n there, n square there, log n square base 2. This can be written as 2 into log n base 2. 2 is a constant, you can ignore, simply log n. Base 2 if you want, you can write. So first loop is log n. Can you see the second loop? Can you see the second loop? I think second loop, if you observe, always into 2. Second loop, if you observe, always into 2. J is equal to 2 into j. Always into 2. It is also log n base 2. So log n base 2, log n base 2. Inner also log n base 2, outer also. Log n base 2 into log n base 2. Log n base 2 into log n base 2. I think log n base 2 whole square. So which will goes to log n base 2 whole square, which is going to be log n base 2 whole square. Question number 33, answer is log n base 2 whole square. Right? Observe clearly. Right? Answer is, I think, same. Time complexity, right? So let's check here. Question number 33. Two inner loops, right? Two inner loops. First one is, outer one is log n base 2, inner one also log n base 2. Right? So finally it is going to be what exactly question is, let me check. So question number 33, one question is given. Time complexity is log n base 2 whole square. Time complexity is log n base 2 whole square because outer one also log n base 2. Check. Inside also log n base 2. Finally log n into log n square. Please check if I done anything wrong. Right? Same answer. So time complexity log n base 2. Log n base 2 whole square. Right? There may be here so many things are there. I think not written clearly. Right? Let me write now. I'm explaining. See this one. Log n base 2 whole square. Time complexity log n base 2 whole square. I will change it. I will change it. So he is asking x value, but our goal is here only time complexity. Here our goal is only time complexity. So please careful. Time complexity of this program log n base 2 whole square. Right? Value also is written, so you can verify yourself. Our goal is only time complexity. Question number 33, answer is log n whole square. See, somewhere small mistake happened, so written also here. Written also, don't worry. But anyhow, log n base 2 whole square. Time complexity of this problem log n base 2 whole square because outer loop also log n, inner loop also log n. Both are log n base 2 whole square. Question number 33. Question number 33. Please verify yourself. Time complexity log n whole square. Right? Outer one, if you see, log n square base 2, which is nothing but 2 log n, which is nothing but log n. Inner one, if you see, always into 2. Always into 2. So log n base 2. Log n times log n whole square. Time complexity log n. There may be some more values he is asking, x value, something like that. You can find out yourself. That is not the goal. Our goal is here time complexity finding. The purpose of this class is time complexity finding. Right? Fine. Come here. Be careful. Question number 33. Sorry, 34. Question number 34. Observe clearly. Observe clearly. Small change may be there. Observe clearly. See this. So always into 2 log n base 2. If n is there log n base 2, n square there log n square base 2, which became 2 log n. Which became 2 log n base 2. Which is nothing but asymptotically, means by neglecting constant log n base 2. So outer loop is log n base 2. Inner loop, if you observe, always plus 2. Always plus 2. N by 2. Right? So n by 2 means n. Inner loops multiply. So time complexity n log n base 2. This is the time complexity. N log n base 2. That is the time complexity. Right? This is. X value, right? You can verify yourself. It is not required because it is a time complexity story only. Time complexity story only. So total, I think I done approximately 35 questions I done. Try to understand. Approximately I done 35 questions, not 1 to 35 questions I done. Approximately 35 questions. So please be careful, right? Today's class, yesterday's class, day before yesterday's class. I done approximately 3 classes I done. I done approximately 3 classes. Time complexity purpose. I done approximately 3 classes. Right. Yes, exactly. right? So yesterday, right, today's class, yesterday's class, day before yesterday's class. If you see all these three problems, right, all these three classes, if you observe, these three classes, if you observe, you are absolutely fine with the time complexity. Similar problems, many problems I done. Similar problems, many I done, not one or two, many. 35 problems I done. 35 problems I done. 35 problems I done, right? If you will going to be very good in time complexity, if you see these three, right? If you see these three classes, if you see these three classes, you are going to be so good. Little doubt also there. You can WhatsApp us. We are going to, right? You can join in our group, right? Group is there. You can join in our group. You can ask the doubts. Join in our group. You can ask your doubts. Right? Just WhatsApp us. We are going to add you. And one more thing is, right? DSA course, right? You people can join. If you want only DSA, you can join the DSA course happily. 80% discount going on. Please utilize. 80% discount going on. Please utilize. Right? Fine. Yeah. Perfect. Thank you so much. And yeah, let me say this also. Let me say this also. Let me say this also. Those people who are interested DSA course, they can join this. DSA plus system design. Right? If you want GATE course, GATE CSC, this one. 1 year course you can join. Next one, right? 2 years course, right? Foundation course you can join. Same thing, GATE DA also. Same thing, GATE DA also. Right? Next one, GATE CSC plus right, advanced, right? GATE CSC plus DSA. This course also you can join. Whatever course you want, you can join. Thank you so much. See you in the next class. Bye. Thanks. Thanks everyone. Thank you. Thank you everyone. Good night.